Okay, so we're talking about 3.5, which is slopes. Hopefully we finish it today, and we can start 3.6. Slopes are actually rates. So yesterday we talked about rates, and we visualize rates, we draw rates. So slope is actually rate. Yeah. Let me open the book, and then we will start. And this is very short. This section is very short, so we will finish it very soon. All right. Now, did anybody try the homework on 3.4 yesterday? How was the homework? No questions? No? It's easy? Or question? It's easy? Okay. All right. Now, rate and slope. Slope is the same as rate. So no question, really. It's easy. Okay, yeah. There's actually not too much on rates. What you need is what? The unit, right? Keep track of the unit. That's it. Okay. All right. So 3.5 slope. Okay. So 3.5 is slopes. So actually, if you think about slopes, is you can think of it as rates. So rate is equivalent to slope, and slope is equivalent to rate. All right. Now, okay, so how do we find slope from the graph? All right. So what is slope or what is rate? So slope is actually, later on we will write it better. So this is change in y, which is vertical change, divided by change in x, which is horizontal change. All right. And people usually say that this is rise over run. And some people also use the formula y2 minus y1 divided by x2 minus x1. Yeah. So slope is m. So the letter that we use for slope is m. I actually don't know. I always want to figure out why do they use m for slope, but I never figured it out. Maybe you guys want to do Google search. Why do they use letter m for slope? I don't know why. So basically, slope is change in y divided by change in x. Yeah. So let's draw these and then see. Let's see here. All right. So suppose you have 2 points. This is x1 comma y1, and this is x2 comma y2. All right. So, and then you have a line through it. Oh, I said a line, right? Okay, maybe let me draw the line first, and then I'll do the x1 and y1. I think that's easier. So this is x2, y2. This is x1, y1. So your slope is change in y, and then this is change in x. So this is change in y, and this is change in x. All right, good. That's what slope is. Now, for example, graph the slope. Okay. Oh, let's just find the traits. Okay. So for example, given the graph, find the rate at which a runner burns calories. Alright, so this is fitness. So the graph looks like this. So this is the minutes spent running. So 2, 4, 6, 8. And then this is the total number of calories. Do you guys keep track of your calories or not? You do? No, I don't either. Yeah, me too. I eat everything, right? Okay. People think, they ask me, are you vegetarian? I said, no, I eat everything. And then, so 2 is 30, 4 is 60. Do you drink? Yes, I drink everything too. But I like water. Vodka, not too much. Maybe a little bit. For some reason, I don't like the taste. What I like is red wine, you know, Merlot, Cabernet. Yeah, but not too like fan. If I don't drink, it's okay. It's not like, oh, I have to have it. No, not like that. Apple juice, I don't drink because it's too sweet. Alright, so this is given. So total number of calories and minutes. Yeah. So some of my friends, they have the Fitbit, you know, the thing they track their calorie, the heart rate, blah 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 blah. Because they're trying to lose weight, and I'm saying, why do you try to lose weight? Just eat healthy and exercise. That's it, right? Yeah. Okay, so what do you think? How do I find the calorie, the rate at which a runner burns the calorie? How do you find the rate? Rise over run. Yes, there you go. So you need to choose 2 points, right? And does it matter which points I choose? No. So I'm going to choose these 2 points. It doesn't matter. I could choose the other points too. Yes? Huh? Yes. As long as it's on the line, any 2 points will give you the same rate or the same slope. Right? Okay, so this is change in y. So rate. So answer. Rate is change in y divided by change in x. Okay, so on the y, I have calories, right? On the x, what do I have? What is the unit? Minutes. So if I use these 2 points, what is the change in y? From here to here. 60? Yes. So it goes up from here to here. You go up how many? 60. From this point to this point, this is the change of y. 30 to 90 is 60. From here to here, how many minutes? 4 minutes. Do you see what I just did? What I did was I start with this point, and then how many units do I go up? So 30 to 90. So I go up how many? 60. And then here I go right how many? 4. So 2 to 6. 6 minus 2 is 4. 60 calories for 4 minutes. So this is 15 calories per minute. Yes? Okay, easy? Okay. So I'm going to do another one like this, and then we're going to do the slope. So you know exactly when you have a graph, then how you find the slope. Yeah. Okay. Cell phone price. How about that? Yeah. So I'm going to talk about cell phone price. You guys ready?
Yes.
Okay. All right. So number 2, this talks about cell phone price. Find the rate of change in the average price of a new cell phone. All right. So this is in 2006, so it's a little outdated. Yeah, this is outdated, right? This is from pricegrabber.com. Oh, it has something like this, so it means it's not up to scale. So this is so 300, 320, 340, 360, 380, 400. Yes, so this is the price, average price of cell phone. Wow, well, this is cheaper. The price of cell phone now is a lot more, isn't it? Don't you think? 340, 360, 380. So so this is March 2005. This is the month. March. Too much. March, July. Let me just do July. So it's 4 months. July 2005. November 2005. March 2006. March 2006. Okay. So in March 2005, in May 2005. Oh, there's no May. Sorry. In March 2005, the price is 380. Sorry. Thank you. And then in March 2006, the price is 320. $380 and $320. So this is your line right here. This should be a straight line, okay? This is 320, and then this is 380. All right. So tell me the rate of price of cell phone. Cell phone price. What is the unit on top? Y, which is dollars, right? How about the unit on the bottom? Month. So how many dollars per month does it decrease? Okay. So are you guys ready? Yeah, okay. So how do I do it? So I'm using these 2 points. Well, I'm only given 2, right? And I will do change in Y. So the change in Y, what is this? So this is 380. Oh, not 300, becomes 320, right? It's too much. Up to 320, then what is the change? 60? Go up or go down? Down. So it is minus 60. Yeah. So if you go down, it's minus. And then let's see here. Do I go right or do I go left? Right is plus. So 12 months. Okay. Minus $60 for 12 months. So how much is it per month? Negative $5 per month. Right? So what does it mean? Every month, the cell phone price decreased by $5. So for example, if you buy iPhone, what? 7 right now? And then, well, according to this, it only decreases $5 a month. Is it true? I think it's more, right? Yeah. So the price of iPhone 7 is, how much is it now? iPhone 7? 700, right? Samsung was 700. iPhone is around that also. Yeah. So I don't think right now the cell phone price is decreasing more. So meaning not $5 a month, but more than $5. Okay, now this is rate, and then let's see about the slope. It's almost the same. It's just that we don't have to worry. Oh, this is dollar, this is month. So I'm going to give you some graph. Find the slope. So 3, find the slope. Is this too easy for you? Find the slope. So I'm going to give you some graph, okay? And all right. So x, y. So you have -3, -3. 1, 2, 3. 1, 2, 3. 1, 2, 3. -3, -3. Okay. And then you have 0, 1. And you also have 3, 5. All right. So this is your graph, and you need to find the slope. So this is A. Let's do B. And put a negative slope. -3, 6. So you have -3, 6. And then you also have -1, 3. And then you have 1, 0. And then you have 5, -6. Oh yeah, 3 points are enough. All right, so I just want you to find the slope. Okay. And then we will talk about parallel, I'm sorry, horizontal line, what the slope is, and then I'm going to give you two numbers and you have to find the slope. Okay. Oh, you're still drawing? What's the slope? Positive or negative? Okay, that's right, but how do you get that? Slope is change in y divided by change in x. So tell me which 2 points you use. Okay, yes, we can. So can you use this point and this point? Of course. Can you use these 2 points? Yeah, so it's just whatever you want. Okay? So let me use this point and this point. Okay? So change in y, let's see. So I'm going to count how many here. 1, 2, 3, 4. So what is the change in y? 4. So 1, 2, 3, 4. Is it positive or negative? Because I go up from here to here, then this is positive. And then change in x. So from here, how many units do I go? 1, 2, 3. So 3. Is it positive or negative? Positive because we go to the right. Go up is positive. Go to the right is? No, right. Right is positive. Yes. Okay? Good. So if you see that if the slope is positive, the line goes up from left to right. Now look at this. The second one, the slope is negative. So let's see, which point do you want to use? So for for B, let's see. So slope again is change in y divided by change in x. All right. So which point? This point? These 2 points? Yeah, it actually doesn't matter. So if I choose these points, now how many units do I go down from here? 1, 2, 3. So I go down 3. So positive or negative? Negative 3. All right. Then I go to the right 2. So it is positive. Negative 3 over 2. Yeah. So if the slope is negative, you see that the line sort of falls. So we always say from left to right. So from left to right, the line falls. Do you see it? If the slope is positive, like A, the line is increasing from left to right and then this is decreasing. Now, what about if you have a horizontal line? Is horizontal line increasing or decreasing? What is the slope of a horizontal line? 0? What about vertical line? So let's graph them. Okay. So rise over run. Yeah. So slope is rise over run. So y over x, etc. So now, what about if I have C, I have a horizontal line. All right. So 1, 2, 3. Let's just say I have this horizontal line. This is 0.3. And I want to know the slope, rise over run. And then I also have a vertical line. And I want to know the slope also. any vertical line. So 1, 2, 3, 4, and then this is a vertical line. This is x-axis, this is y-axis. By the way, the equation of this line is y equals 3. And the equation of this vertical line is x equals -0. Right? All right, so what do you think? So what would you do here to find the slope? Well, then I just choose another point, right? What's my other point? Let's just say I'm going to choose this point. Can I choose 3,0? No, I need to choose any points on this line. 3,3? Yeah. Okay, good. So slope is rise over run. So slope, we use letter M for slope, is rise over run. How many units do I go up and down here? 0. Do I go up and down? No. How many units do I go left and right? 3. What is 0 divided by 3? 0. Yes. So the slope of any horizontal line which has equation y equals k is 0. So y equals k is a horizontal line. Yeah. All right, now the D. Undefined for D? Yeah. Why is that? Yes, that's right. So slope is rise over run, but let's see, let's choose 2 points first. So suppose I choose this point, and maybe what else do I choose? Maybe this point? So this is -2,0. What about these? -2,3. So why do I choose -2,3? Any idea? It is up to me what point I choose, as long as what? It's on the line. Yes. So it doesn't matter what point I choose. So in this case, what is my rise here? 3? Positive or negative? Positive, yes. What is my run? Do I go left and right? No, 0. So this is undefined. So for any vertical line, the slope is undefined. Yes? So the slope of any vertical line, and then the equation is x equals to k, k is any number, is undefined. All right. Yes? So 0 is because there is no rise, and undefined because there is no run. Run is 0. So run is always 0 for vertical line. Rise is always 0 for horizontal line. Yeah? Okay. Easy? All right. Did I label A, B, C or no? No, I don't? Oh, no. Okay, that's fine. Continue? Okay, so let's continue. So the next one is, all right, so for example, find the slope given 2 points. Given points. All right, so let's see. Number 1. 1, 3 and 5, 8. And then number 2, -2, 4 and 3, 0. Okay. And then number 3, -5, -1 and 2, -3. So how do you do it? So slope is, are you going to graph it? No, not necessary. We'll just use what? The y2, change in y. What is change in y? y2 minus y1 divided by x2 minus x1. All right. So change in y divided by change in x. y2 minus y1. What is y2 minus y1? 8 minus 3 divided by 5 minus 1. So what's that? 5/4. Finish. Can you do number 2 and 3 really quick? So what's the slope? What's the formula? y2 minus y1 over x2 minus x1. If you write it, then you'll remember. Make sure to write the formula all the time. Yeah. We're not even graphing here. Yeah. Yeah. So you know how to do it twice. If you're given the graph, then you know how to find the slope. If you're given the point, you know how to find it also. Yeah. Sure. So y2 minus y1. What is y2 minus y1 here? 0 minus 4 divided by x2 minus x1. 3 minus -2. Not 2, but 3 minus -2. So -4 divided by 5. Finish. Yeah. Okay. So next one, number 3. So Ellen, can you put your phone on my desk, please? What is the slope? On my desk. And then pick up your test. What formula? y2 minus y1 divided by x2 minus x1. Yeah. Or easy, could you just put it over there. Later on you can pick it up, okay? So y2 minus y1 is -3 minus -1 divided by 2 minus -5. Yes. So this is -3 plus 1. What is -3 plus 1? -2 divided by 7. Finish. So easy? Okay. Now, what about this? Find the slope. Wow, I'm giving you easy stuff, huh? Given equation. This is easy also. Y equals -2. 2 X equals 5. 3. Y equals 4. So y equals -2. What is the slope? 0. Why is it 0? This is horizontal, right? Horizontal line. So what is it? Rise is 0. If it is horizontal, you have no rise. So slope is 0. That's it. Finish. So y equals -2. You know it's a horizontal line, right? Okay. What about x equals 5? Why is it undefined? The vertical line. So if you remember vertical line, which one is 0? Run is 0, so slope is undefined. Good. I'm glad. What about y equals 4? 0 also. This is getting boring, isn't it? Too easy. Yeah. Okay. Now a little more. This is like surveying, and it's talking about the grade. Yeah. Okay. Like grade, you know, the steepness of the road, steepness of roof, things like that. All right. So maybe this is in application. So this is application. Yeah. So maybe I didn't do A, B, C, D, but I'm just going to put this application. So application. All right. You want to go skiing? Okay, so this is the steepest sky above terrain in North America. Okay. So this is skiing. I don't go skiing, by the way, but some of you do, right? No? Yeah, I know. I'm scared also. So among the steepest terrain in North America, the head wall on Mount Washington in New Hampshire drops 720 feet over a horizontal distance of 900 feet. And then it says, find the grade of the head wall. So the grade, what does it mean? This is just the slope, but expressed in percent. So you have to find the slope, but then you have to change it to percent, basically. That's what it is. Okay. All right. And then we don't have negative here because the grade is, well, I mean, when we talk about the grade, it's always positive. So can we draw it? How does it look? So, all right. So what am I supposed to do here? So how many feet here? So you're here with your ski, whatever. So 720, the height is 720 feet? Okay. And what about the horizontal distance? So from here to here is 900 feet. All right, so you're going to go from here to here. If it were me, I would die. Because I will be scared, right? I mean, All right. So this is the head wall. They call it the head wall on Mount Washington. Yeah. So can you tell me what the slope is? Yes, 720 over 900. And then you have to change it to percent. Why not 900 over 720? Yeah, so it has to be rise over run. Yes? And here we don't consider any sign. Yeah, so when we talk about grade, what is the grade? It's not the same. So this is it 0.8, which is 80%. Yes, 80%. So the grade is 80%. So basically, what is grade? It's just a slope, but what? You write it in percent. That's it. Yes, so rate is the same as slope, as the same as grade, but the grade is expressed in percent. Is it easy? Oh, yes. Okay, so I'm done with 3.5. Yeah. And we should start 3.6. So here, slope intercept form, so you have to pay attention a little bit. Why? It's easy also. Why? This is still early morning. This is still early morning. Same as me. Okay. All right. So now, let's see. New section. Oh, where is new section? 3.6. Okay, so slope intercept form. What are you guys doing? You know what happened? I know, you've been driving since what time? 5 o'clock today? Oh gosh. Yes. But you still get here on time, don't you? Yeah, that's good. Yeah. Yes. That means you want to try, right? Yeah. Huh? That means you need to sleep? Yes, you will. I know that. Yes. So, what we want to do here is talk about the, so we're going to graph using slope and y-intercept. All right. So, for example, I would like to draw, so for example, draw a line with slope -3 over 2 and y-intercept 0,2. All right. So what do I mean by that? That's right. But where do you start? Point. Yeah. Yeah, that's right. Yeah. All right. Good. So this is easy also. See, today is very easy, relaxed, right? So 0,2, where is 0,2? I have to start with the y-intercept, 0,2. Okay. And then what do I do? So the slope is -3 over 2. So this is rise. And this is run. So rise is -3. So I'm going to go down 3. So 1, 2, 3. Because I'm going to go down 3. And how many units do I go? To the right 2. Okay. So I find my point. What is this point? I have to label this. 2, comma. All right. There you go. So then you could connect these. For me, it's a little bit harder. So you can use straight line, right? Draw straight line. All right. Is it easy?
You go to the right twice, whatever we go to the left.
Or,
Yeah,
okay. Or if you say, oh, I'm going to use -3/2 as 3/-2. Okay. Is -3/2 same as 3/-2? Yes. So let's just say, I don't want to do -3/2 like this. I want to use it as 3/-2. So if this is your rise and this is your run, then what? So here I go, how many units up? 3. So just say, oh, I want to be playful today. This is too boring. I'm going to write my -3/2 as 3/-2. Yeah. So I'm going to go up 3. So 1, 2, 3. All right. And then to the left 2. 1, 2. So this is my claim. Let me see. This is 2, 3, 4, 5. So 5, -2? Yes.
No, I mean, in the first example, you know how you went to the right?
Mm-hmm.
You can't go to the left?
You cannot, because this is +2.
Oh, I see.
Here, why do I go to the left? Yes. Right? So if you associate the negative with the 3, then you go down.
If -3/2 is the same as 3/-3, then why are we going to go up?
It's the same line. If you see this, if I connect this, then I still have the same line. So it doesn't matter. Yeah. So I could do this way, or I could do this way, and I will still get the same line. So I mean, this line is too short. Otherwise, it's longer and it passes that point. So it doesn't matter. -3/2 or 3/-2. Okay. Yeah. Yes. Yes. 3, 4, and 3, 5. 3, 6, we're not done. Yeah. Unless we could get it done. Okay, so let's see. Okay, so now let's talk about the slope-intercept equation. So slope-intercept equation. We still have 15 minutes. We might get it done. But you guys finished 3.4, right? 3.5 will take you 20 minutes, 30 minutes, yeah.
So, going back to that.
Okay, can you guys listen? Hugo has a question. Yes. If last section, The formula, it's better. You know why you have to write it down? So that 10 times you write it, then it's fixed here. y2 minus y1 over x2 minus x1. Number 2, m equals y2 minus y1 over x2 minus x1. Number 3, m equals y2 minus y1 over x2 minus x1. Tonight when you sleep, m equals y2 minus y1 over x2 minus x1. Yes? No, you don't. The thing is, the rise over run, it's easier to see when you have the graph, right? But y2 minus y, if you're given the points, then you're practically using y2 minus y1 over x2 minus x1. Yeah, if you have the graph, then we use rise over run. Because you're going to count, oh, this is going to go down 3. Then you use y2 minus y1, right? Because if you say rise over run, then you have to figure out the rise, and it's a little bit harder. Yeah, because you're not graphing. Yeah. Yes, you can. Yeah. Okay? All right. So it's the same formula, rise over run. So the slope-intercept equation is this. Y equals mx plus b. So far, we learned 2 formulas already. The first one is the slope. This is the second formula. Right? Slope is rise over run, or y2 minus y1 over x2 minus x1. What is m here? Slope. And your 0, b is the y-intercept. All right. So this is slope-intercept equation. So y equals mx plus b. Okay. So, for example, find the slope and y-intercept, and then graph. Then graph. All right. So find the slope and y-intercept, and then graph. Okay, so, oh, you guys are not done, right? Sorry. Let me put it back. I'm sorry. I didn't write down the formula. Ready? Okay. So, number 1. Y is equal to negative 3x plus 4. And then number 2, 2x minus y is equal to 5. Number 3, 3x plus 4y is equal to 8. All right. So, for number 1, do we know what the slope is? Yes. What is the slope? Negative 3. And there is an invisible over 1. We don't write it. You know, my pre-calculus student, the answer is x in Math Excel. And then he put in x over 1. And then Math Excel marked him wrong. And then he's angry. Does it make sense? No, this is... I looked at his answer. He says this is correct. How come Math Excel says it's wrong? Well, you entered x over 1. Would you enter x over 1? No, right? I mean, it's just intuitive, or I mean, common sense. Would you enter your answer 2 and then you answer 2 over 1? No, right? Okay. No, it's wrong because we never do it that way. Right? Okay, so what is the y-intercept? 0,4. Yeah, good. So now when we graph, do we know how to graph it? Okay, so where do we start? Yes, 3, 4. There you go. So 0,4 right here. Okay, good. Then what do I do? This is negative 3 what? Over 1. Do I write the over 1? No, I don't. I mean, I'm smart, right? You're smart. So you don't. You know it's negative 3 over 1. Yes, so we go down 3. So 1, 2, 3, and then go to the right 1, and then write the point here. What is this? 1, comma 1, and then we draw the line. Period. Finish. That's it. That's how easy it is. Okay. Is it easy?
Yes.
Yes. Okay, good. Now, number 2, we have to solve for y first, don't we? Okay, how do I solve for y? So negative y is equal to, oh, then I say, well, I have to move the 2x to the other side. So it becomes negative 2x plus 5. Now, what is y? This is negative y, so I need y. Y is 2x minus 5. So how do I get 2x minus 5? By negative 1? Yeah, okay. So y is 2x minus 5. Do I know the slope now? It is 2, and y-intercept? Okay. See, it's easy also. Do you know how to graph it? So this is another way to graph. So remember before you wrote 3 points, remember that? Now you write it as y equals mx plus b and then graph. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so I start with 0, -5. I'm going to label this. Alright, and this is X, this is Y. So we always label our points. And then what do? The slope is 2, and you know that is 2 over 1. And I don't write the 1. I'm smart, right? So what do I do here? What do I do from this point? Go up 2? And then go to the right or left? Okay, so this is comma. Yes. And then we just smartly draw the line. Okay. Is it easy? Okay. Good. Can you do number 3 for me then? Yeah, so you have to solve for y first. Okay. Okay. So, okay, I think even though I'm almost done, let's just make the 3.6 due on Sunday, right? So, tomorrow night, 3, 4, 3, 5. Yeah? Okay. But I just want to let you know we're almost done. We're going to talk about parallel perpendicular lines, which is 10, 15 minutes, and then 3.7 tomorrow, and also start 8.1. Yeah. Are you ready? What's the slope? So what is it? 4y is equal to 4y is equal to what? Negative 3x plus 8. Yes. Good. And then divide by 4. Yes. Good. So y is equal to negative 3 over 4x plus 2. All right. Do we know the slope? Yes. What? Negative 3 over 4. Do you want the negative to be on top or on the bottom? On top. So write it like that. Yeah. And then 0, 2. Okay. Then we graph. So 0, 2 is right here. And then what do we do? Go down 3. So 1, 2, 3. Okay, and then go to the right 4. 1, 2, 3, 4. Oh, I'm missing one thing here. What's my coordinate? 4, negative 1. Yes. All right. Good. Okay, it's supposed to be straight. Okay. You can use your imagination. This is straight. Yes. Okay. So, do you want to discuss parallel perpendicular lines now? What did you say, Vanessa? Oh, sure. Okay, I could let you guys go a little bit early today. I want to discuss parallel perpendicular lines, but okay, tomorrow's fine. Yeah. Okay, guys. I will see you tomorrow. So we will finish the parallel perpendicular lines, and then start 3.7. Okay. All right. So just do the homework today because it's easy anyway. It's not going to take that long. Oh. As soon as she's done, I'm gonna close it. Yeah. Give me a second. Okay. See you tomorrow. Oh, Ellen, your phone. Yeah. See you.
Do you want me to the paper?
No, but you know how to do that. That's the most important. Good job. So next time, if you need help, do it before, right? You get 100. Finish? Okay. Let me close this, save it, and then, so we're almost done with 3.6. Oh, actually, we're almost done with slope intercept form. And tomorrow we will finish it.